Welcome to Tapovan, where learning meets stillness, where we learn deeply with code. In this day 2 of JavaScript series, we learn the tale of the two worlds. When we are writing JavaScript, we are mostly working with data. Sometimes the data is simple, a number, a word, true, false. Sometimes it is more complex, user details, product list, config settings of an application. And how JavaScript stores these values are very different under the hood. One is stored by value, the other by reference. And if we don't really understand this deeply, bugs will sneak into our code without any warning. In this video, we are going to learn two core data types in JavaScript: primitive types for simpler values and reference type for our complex structures. We'll explore how they live in memory, how copying and comparison behave, and why mutation works the way it does. And along the way, we'll develop mental models to build intuition, not just memorization. Let us see some examples of primitive and reference type. We'll start with primitive. Your primitive types can think of them as raw, very simple values. They can be a string like Tapovan. It can be a number, let's say age, 1 month old. It can be a boolean. Are we happy doing this? Yes, true. Your reference types, think of these as more complex structures, and these are stored by address. It can be a user object where we have a name property and age. It can be an array, colors, and we can have multiple entries, red and blue. Why is this distinction important? Because how JavaScript copies, stores, and compares these values under the hood are very different. Let us now create a mental model to understand this. Consider primitives like token. For example, you have two 10 rupee notes, you give one to your friend. They have their own 10 rupee. Right now, how they spend is not of your concern. Change in one does not impact the other. That is primitive, value passed by copy. Now consider a situation where you are collaborating with your friend on an online document, right, which is shared to both of you. If you make a change in that notebook, it is reflected to your friend as well, and vice versa. That is what reference types are. Now that you know that there are two types of data, primitive and reference, let us go a level deep. Where are they stored in memory when your code runs? The answer is JS stores values in two types of places: stacks for your simpler, your primitive values, and heaps for your complex structures, your reference types. For example, when we do something like this, let a equals to 10, and then we try to make a copy by creating another variable pointing to our former one. What happens here is a copy is made, my dear friend. It's like place a new box is created, a value of 10 is created, placed in that box. Two separate boxes are now there, placed in stack, placed in a new box. Both A and B live in the stack, each have their own copy of the value 10. Now let's consider for heap. Heap is where your complex data is stored. Now pay attention. Stack holds a variable that points to the memory address, the reference where the objects and arrays are stored in heap. Let's break this down. What I'm saying basically is, let's say if I'm creating a variable array with content 1, 2, 3, and then if I create another array pointing to array 1, is this a new array? This does not point to a new array. This is just a new pointer. Both array 1 and array 2 are pointing to the same array in the heap. Let's visualize this little deeply. So my array 1, let's say, is pointing to a memory address, let's say 0x1a2b. Correct? This is a memory address. Now, when I created array2 equals to array1, effectively what I did is I created a new variable in stack which is also pointing to same memory address 1A2B, correct? So in your heap, your 0, 1A, 2B contains the array 1, 2, and 3. So when we do something like this, array2 dot push 4, you're modifying the same array in the heap. Both array1 and array2 will see the change. Why this matters? Now, understanding this particular idea helps us understand a lot of common JavaScript behavior. Why changing one object will change the other. Why comparison using a strict equality operator result false for the same looking array. Why copying objects needs special care. Now, understanding where data lives helps us reason why it behaves the way it does. Okay, so now you understand what two core data types are, where they live in memory. Now, what happens when you try to copy or change these values? That is where things starts getting interesting. And that is the place where many real world bugs are born. Let us see some examples. Let's say if I'm create a variable score1, give it a value 100. I say score2 points to score1, correct? And later if I update my score2 to a value 200, will this make a difference in my score1? The answer is no. My score1 will still point to 100, correct? And of course, my score2 will have become 200. Straightforward. These are example of primitives. When we assigned score2 equals to score1, JavaScript made a new copy. Changing one has no impact over the other, right? Now let's look at the other interesting bit, which is changing the reference, the same shared scroll or the shared notebook. Let's say we create a variable and the name goes by Tapovan. Maybe let's add a level. Level is 1. Let's create another player 2, now pointing to player 1. If I make player 2 dot level, increase it to 2, my dear friend, player 1 dot level would have also become 2, correct? And we discussed this just few minutes back that player 1 and player 2 are reference types. They are pointing to the very same object in the heap. These player 1 and player 2 are this player 1 and player 2 are the variables in your stack pointing to the same memory address, same object in the heap, right? All right, now that you have discussed about copying reference type, there are two important jargons that come into play. First is mutation. Mutation. What does this mean, my dear friend? It means changing the internal content of reference types, which is our objects and array. The second jargon that we should be aware is the term that goes by reassignment. What does it mean? It means pointing to a whole new object or array. All right. So let's say if I create a array 1 comma 2, and if I create a copy pointing to my array, okay. Now if I do something like this, copy dot push 3, what are we doing? Is it mutation or reassignment? This is, my dear friend, is mutation, right? It affects both. When you're mutating it, you're affecting both the variables or multiple variables in this, whatever the case might be. If, however, we do something like this, copy is equals to pointing to 4, comma 5. Now, in this case, this becomes reassignment. Now, the copy variable points to a different memory address altogether, correct? All right, now let's move to a very interesting concept of cloning objects and the idea of shallow versus deep copy. Now, when you're working with objects and arrays, your reference types, copying them is not always straightforward. Sometimes you think you have made a copy, but the original one still gets changed, and that's a bummer. Let's try to understand why that happens. We'll discuss shallow copy using a very interesting special operator, which is known as your spread operator. And how do we, what is the way to basically represent that operator? It's three dots. Okay. So let's see an example. Let's create a variable ashram, and maybe it has a location property initially. Let's give it Himalayas. Okay. And what practices are taught? Maybe meditation, and maybe the practice of silence, observing silence, right? Now, if I have to create a cloned copy of this ashram such that these are two different objects, what I'll do is I'll use the spread operator. So it spreads out the property and creates a new reference altogether. Correct? Now, how do I confirm this? If I do cloned ashram and change the location and point it to another beautiful place, which is, let's say, Kerala. If you have not visited, please do plan to visit Kerala as well. Now, what happens if I change the location of my cloned ashram? What happens to my original ashram? Will it also become Kerala? No, no, no. This will remain Himalayas, right? That is what your spread operator does. Your top level properties are copied. So changing location in your cloned ashram did not change the location in the original ashram, right? This part works as expected. But what about the nested structure? Now, this property in ashram is an array. It could be an object, it could be an array. The idea is if this is a reference type, then let's see what happens. Let's see a case where we are doing cloned ashram and we change the practices. We try to push a new practice, maybe the idea of offering service. Now, what happens to my ashram.practices? This, my dear friend, also gets affected, and we see that we'll have the new practice getting added for my original object as well. Why did this happen? The array ashram, the array practices was not deeply copied. It is still a shared reference between the two objects. This is, my dear friend, the result of a shallow copy. Only the top level properties are copied, not the nested ones. Right? Why is it important? Why does this matter? Why are we discussing this? In real applications, when you'll work with objects and arrays, objects that contain arrays, arrays that contain objects or nested objects, if you assume that a spread copy will give you a fully independent object, that is where the bugs will slip in. And how do we fix this? We fix this by creating a deep copy of the object. Okay? And a full exhaustive way to do a deep copy of a nested object is something which we'll discuss in the coming classes. But at this moment, I want to give you a shortcut, a hack to kind of do this. And it goes like this. To create a deep copy, you follow a two-step process. You use json.parse. Basically, we first try to stringify the object. We try to first stringify the object. So this part converts my object into a valid JSON string, and then we will parse it back to into an object. So first convert it to a JSON string and then convert it back to an object. Now this two-step approach will break all the references and give you a fully new independent object. Right? But it comes with a limitation. Having said that, having shared this, it comes with a limitation. Do you remember that? Your functions, your undefined, your circular references are lost. And basically, we'll discuss the deep copy approach in a more exhaustive way to do that in the coming classes. What should be your takeaway at this moment is that the spread operator gives you a new object, but it will still share the inner values Your nested properties will still have a shared reference unless we explicitly do a deep copy of the object. Okay, now you understand the two core data types, how they are stored in memory, how copying and mutation works differently for them. Let us see a couple of examples where learners get confused often. Okay, let's say I have a variable that has the content wisdom. Okay, let's create another variable that also contains the content wisdom. So these two are two different arrays, two similar looking arrays containing the content wisdom. Now, if I try to compare scroll 1 with scroll 2, what will this result? Will it be true? Will it be false? It will be false, right? Because even though these two arrays look the same, they live in two different places in memory, correct? And the triple equals to basically the scroll will point to a different memory address, the scroll 2 will point to a different memory address, and this will result in false. If we, however, do something like this, let's say scroll, same scroll pointing, we assign it to the scroll variable, and then if we try to compare same scroll to scroll, this will definitely be true, right? So don't get confused if you see two similar looking arrays, right? These are two different memory references altogether. All right, let's see one more example where we have a function, let's say enroll student. It accepts an argument student, and inside this function, let's say we are doing something like student dot enrolled is equals to true. Okay. Now let's say we have a student object where we have a property name, and let's give it a value named Rishi. I pass my student inside the function. Okay. Later, if I try to do something like this, student dot enrolled, what will be the result? My original student object was named Rishi. I passed it into enrolled student, and I'm trying to basically check the enrolled value. All right, let's just maybe give it a different name so that the difference is more obvious. Let's have a variable named record and pass that record in the function. And later, I try to check record.enrolled. Now, what happens? This will be true. Why? Because what we have done is we've actually passed a reference in our function, right? And the function mutated the original object because it received a reference, not a copy. How to avoid this? If you want to avoid this, create a clone before making any changes. Some thoughts arise and pass, self-contained, untouched, just like primitives. They don't change us. But some thoughts linger, they connect and mutate and change what follows. In beginning to see the code deeply, we start seeing things in ourselves. With that food for thought, I'll take your leave and see you in the next video. Thank you.